There are many different applications that can be solved using percentages. This video is going to cover how to set up applications that involve percent, including percent increase and decrease, as well as simple interest. So let's just dive into an example. On a 120 question test, a student answered 96 questions correctly. What percent did the student do correctly? So in this problem, we can choose to set up either an equation or a proportion. I'm going to set this one up using a proportion. The proportion is percent over 100 equals part over total. This problem is asking us to find what percent. So the unknown in this problem is the percent. So I'm going to put the x over 100. So we're solving for the percent, so x over 100. The total number of questions on the test is 120. So on the right side of my proportion, the 120 goes on the bottom. That is the total. And then finally, 96 is the part of the test that was done correctly. So 96 would go on the top of my proportion. I can solve this by setting the cross products equal. 120 times x equals 96 times 100. So 120x equals 9600. To solve, we divide both sides by 120. Before I do the division, I might as well reduce by a factor of 10. So 960 divided by 12. 12 goes into 96, exactly 8 times. So then 12 goes into 0 times, and x equals 80. Because I used a proportion, the 80 is my percentage. I don't have to move the decimal. So x equals 80. My final answer would be 80%. The student got 80% of the questions correct. Here's another example. A survey asked 300 students how they get to school. If 40% said they take the bus, how many students responded that they take the bus? So in this problem, we are given the percentage. That's going to go over 100. And the 300 is the total number of students that were surveyed. We're trying to find the part of the survey that said they take the bus. So my proportion turns into 40 over 100. 40 is the percent, so it goes over 100. 300 is my total. That goes on the bottom. And we're solving for the part, so I put an x on the top of the right side of the proportion. Now we can set our cross products equal. 100 times x equals 40 times 300. 40 times 300, let's see, 4 times 3 is 12. And then there's a total of 1, 2, 3 zeros. So 12 with 3 zeros, 12,000. 100x equals 12,000. Divide both sides by 100. X is 120. So 120 students said they take the bus. Next example. In a shipment of airline parts, 3% are known to be defective. If 15 parts are defective, how many parts were in the shipment? So in this problem, they gave us the percentage, the 3%. They told us the number of parts that were defective. We need to find the total number of parts in the shipment. So when I set up my proportion, 3% becomes 3 over 100. 15 is the proportion of the shipment that was defective, and so x is my total. I'm solving for the total number of parts in the shipment. We can solve by setting our cross products equal. 3 times x equals 15 times 100. So 3x equals 1500. Divide both sides by 3. Let's see, 15 divided by 3 is 5. So 1,500 divided by 3 would be 500. So there must have been a total of 500 parts in that shipment. My next example is a little bit different. Let's read through it and then talk about how to solve it. If a person earns $42,000 a year and gets a 5% increase in salary, what will their new salary be? So this problem is actually dealing with a percent increase. And when you're working with percent increase or decrease, the problem actually becomes a two-step problem. The first thing we have to do is figure out what is 5% of 42,000. That's the raise. And then once we compute that raise, we'll add it onto the salary. So to find 5% of 42,000, there's two different ways we can do this. We can write a proportion. 5% goes over 100. 42,000 is the total salary. The raise is just part of that salary. So the X goes above the 42,000. And we can solve this by cross-multiplying. We can also use that equation method on these problems. So if we want to find 5% of 42,000, we can take the 5%, move the decimal 2 places to the left, so 0.05, and we can just multiply that by 42,000. 5% of 42,000 is 0.05 times 42,000. And then 5 times 42,000, we get 0, 0, 0, 10. Carry the 1. 20 plus 1 is 21. There's 2 places after the decimal, so my product has 1, 2 places after the decimal. That is $2,100. And this is not actually the final answer. We're not done with the problem. We have just figured out that 5% of 42,000 is $2,100. This is the amount of the increase. This means this person will get a $2,100 raise. So the amount of the new salary would be 42,000 plus 2,100, which is 44,100. So when you're dealing with percent increase or decrease, you want to find the amount of the increase or decrease first, and then if it's increase, you add that amount. If it's a decrease problem, like maybe something's on sale, then you would subtract the value that you find. So there's 2 steps involved in this problem. Now, if you're trying to find a percent change, a percent increase or decrease, we can set up a proportion. But again, as we'll see in my examples, the problems are going to involve 2 steps. And when we set up our proportion, the percent will still go over 100, but we'll be talking about percent change. The part is going to be the amount of the change. How much did the value increase or decrease? And the total is always going to be the original amount. And so let's see how this works by doing a couple of examples. Shoes that usually cost $25 are on sale for $21. What is the percent discount? So we're solving for a percent change. In this case, it's a percent decrease. So the first thing we have to do is figure out how much did the price change. 25 minus 21 is 4. So the price went down by $4. That's the first step. And now we can set up our proportion. We're solving for the percent, so X over 100. And the part is the amount of the change. How much did the price go down by? So this is going to equal 4. 4 is the part over. And then the total is always going to be the original amount, the amount before the change. So in this case, that would be the $25, the starting amount. So my proportion is X over 100 equals 4 over 25. We can set our cross products equal. 25 times X equals 4 times 100, or 400. And then we can divide both sides by 25. 400 divided by 25 should be 16. I use long division over to the right. Sometimes when I'm dividing by 25, though, I just think about money, like how many quarters are in $4. Should be 16. So X is 16, and that is my percentage. So we had a 16% discount in the price of these shoes. Let's do a second example. The population of a country has increased from 4 million to 5 million. What is the percent increase? So the first step is to find the change in population. We went from 4 million to 5 million, so the population went up by 1 million. 5 minus 4 is 1. To get my proportion, we're solving for the percent, so X over 100 equals, the part is the amount of the change. How much did the population change by? That was 1 million. And then the total is going to be the original amount, the amount before the increase, the starting population, which was 4 million. So X over 100 equals 1/4. Oh, so in this case, actually, we're trying to figure out what percent is equal to a fourth, a quarter. Should be 25%. Let's do the math and see if we get that. So cross products would be 4 times X equals 1 times 100. So 4X equals 100. Divide by 4. Yep, 100 divided by 4 is 25. So there was a 25% increase in population. Finally, the last application I'd like to show you is simple interest. And when we're solving simple interest problems, we are going to use the formula that I have on the screen. I equals PRT. I stands for interest, so it's the amount of interest you earn or have to pay, depending on the context. So the interest is going to be a money amount, monetary amount. P stands for principal. That's the initial amount that you invest, or in some cases it might be an amount of money that you borrow. So that's your principal or starting value. R stands for your interest rate. That's where your percentage goes. And we're always going to write that interest rate as a decimal. And T stands for time. And because interest rates are always given as annual or yearly interest rates, we have to always make sure our time is given in years. So let's do a couple examples that involve simple interest. Allison borrows $8,000 at 12% simple interest. How much interest will she owe after 3 years? What is the total amount that she will owe after those 3 years? So my formula, I equals PRT. If we want to find the amount of interest that she will owe, we're solving for I. The P, the principal, is the amount she borrows, so that's the $8,000. R is my interest rate, 12%. We have to take the decimal and move it 2 places to the left, so 12% becomes 0.12. Time is 3 years. So I'm going to plug those numbers into my formula. I equals 8,000 times 0.12 times 3. To multiply, pick any 2 numbers you want to multiply together first. I did 0.12 times 3 is 0.36. And so now I have to do 8,000 times 0.36. I have my work written out over to the right. But my final answer was 2,880. So the amount of interest that she will owe after 3 years is $2,880. Now there is a second question in this problem. They're asking, what is the total amount that she will owe? How much money will she actually have to pay back? So she borrowed $8,000, and now she has to pay back over $2,000 in interest. So the total amount of money that she's going to have to pay is her original $8,000 plus the interest. So $10,880. It's kind of like a percent increase problem. The interest increases the amount that she has to pay back. Here's my second example. Jesse invests $1,200 in an account that pays simple interest. After 6 months, he has earned $36 in interest. What is the interest rate? So we'll use our simple interest formula, I equals PRT. In this case, the interest earned is given to us. The I is the $36. The principal, the amount of money he invested, is the $1,200. They're asking us what is the interest rate, so we don't actually know the R. We're going to be solving for R. And then the time is given to us, that was 6 months. We have to be a little bit careful in this example though, because time is always going to be measured in years in these problems. And so 6 months, we can do 6 over 12, that's a half. 6 months is a half of year. So we're gonna have to plug in a half, or we could do 0.5 in for time. Okay, so 36 equals 1,200. We don't know R, times a half. To solve this problem, I'm going to start by taking the 1,200 times a half. We can multiply in any order we want, so we can take the 1,200 times a half, and that's 600. Half of 1,200 is 600. So now I have the equation 36 equals 600R. To get R by itself, I'm going to divide both sides by 600. So R is 36 divided by 600. This is going to be my interest rate or my percent. So a couple ways we can actually finish this. This is going to be a percentage as a decimal. But I know that percentages are always over 100. So notice if you take this fraction 36 over 600 and you divide the top and bottom by 6, it simplifies down to 6 over 100. 6 over 100 is 6%. Right? Percentages are always over 100. So 6% is my interest rate. Now, if that doesn't make sense to you, you can definitely use long division and take 36 and divide it by 600. You'll have to add a decimal and some zeros, but 600 goes into 3,600 6 times, so you end up getting 0.06. And then to change that into a percent, you have to move the decimal 2 places to the right. So 0.06 is 6%. Another way of getting the same answer, the simple interest rate must be 6%. All right, that was the last example. Again, reach out if anything is unclear.